Hey folks, Mr. Dell here. We are looking at a proof. So we do already have some of the proof. We have all the statements. So in some of the reasons, so we need to complete this proof. Actually, some of the statements we need to complete. So statements and reasons, there's some blanks that we need to complete on this proof. So we're going to go through this process. I'll walk you through the logical steps here. So this is coming from Math, CPM's Math 2. And this is section 7.2.1. This is number 7-73. So it says Suzette started a proof to show that BC is parallel to EF and AB is parallel to DE and AF is equal to DC, is congruent to DC. Then, okay, so that's my given, right? This is if. So to show that if, when you see this, if all of this is true, then, so this is where we want to end. This is our proof. So if all that's true, then BC is congruent to EF. So examine her work below and then complete her missing statements and reasons. So the first statement here is BC is parallel to EF. Well, that's what we started with. So what we'll write here is that's our given. That's the given, because it's given in our beginning proof in our statement here, what we have written. Suzette wanted to show that if, right, if all of these things, then this. So that's a given. We can also look for the other givens. Really, honestly, we can see this here. This AB is parallel to DE. We can also see that's a given, and that's a statement that we have. So that's also given. And then we also know it was AF is equal to DC. So once again, that's also a given. So we can write given as our reasons for each of those, because that's what up there, each of those three things are given. So let's fill in the other one. So once we know that BC is parallel to EF, so BC is this one, is parallel to EF, that one. It says that angle BCF is equal to the measure of angle EFC. So where are those angles? BCF, right? So BCF is this angle here, and then EFD, so that's this angle here. So those are congruent. Why? Well, because we're looking at this here being the transversal. So we have two parallel lines, right? If I could just continue those, two parallel lines cut by a transversal. So you have what we call those alternate interior angles. So we would say alternate interior angles of parallel lines are congruent or equal. Okay, we'll just say are equal. All right, so then from there, we have another statement. So I'm going to erase my work here because I'm now going to highlight the other piece here, which is this AB. It says AB is parallel to DE, and it then from there it says that angle, what angle BAC? So BAC, that's this one here, and angle EDF, that would be this one here, are congruent, are equal. Why? Because once again, here I have a transversal cut, and these two lines are my parallel lines, right? So those two are the parallel lines. So there's my transversal. And once again, another statement of alternate interior angles of parallel lines. Oops. Are equal. Okay, so same reason as number two. Now we go in and we know AF. So AF, let me get rid of my drawing here so I can keep marking this up to see where I'm at. So AF is equal to DC. AF is this, and DC is this. So those are equal because it's given. And then it says reflexive property. So what would we have that reflexive meaning same side, right? It's same side is reflexive. That's what this idea of reflexive property is, same side. So I think I want to say, if I look forward here on the next statement on 7, it talks about AF plus FC is equal to FC plus DC, right? So I'm pretty sure that they're wanting to show that those FCs are equal to each other. So we would say that FC is equal to FC, right? FC is this piece and it's equal to itself, and that makes sense. It's the reflexive property, right? So then what happens once we did that? Then they can build this statement that basically, if those are equal to each other, and then I can take AF plus FC, because it's equal to then FC also equal to DC. So this plus this, you're adding the two sides of the equation, if you will. So then that gives us our reason. And the reason is addition property of equality. So, and they give a little bit more detail. Adding the same amount to both sides of the equation keeps the equation true. So that's what we're doing. We're adding FC to both sides of this equation, and it's okay to do that by the addition property of equality. Then AC, it says AC is equal to DF by segment addition, right? So if I add those two segments, AF plus FC, if you look at my picture, right? AF plus FC is the same thing as AC, right? A to C. And then the same thing isn't true over here. So FC plus DC is totally the same thing as from F to D. So it shows DF. So they say AF equals DF because of segment addition. All right. We're almost there. So now now I know that triangle ABC is congruent to DEF. That should be a triangle symbol, triangle DEF. So, all right, how do I know they're congruent? Well, I have congruent sides, right? I have AC. AC is congruent to FD. I also know that BC from here, let's see, the given AF. Oh no, I don't need that one. Let's see. Oh, angles. This angle here. I have these angles, right? So I have the two angles. I have BCF, which is right here, is congruent to EFD. So I showed those congruent. And then I showed that BAC, angle BAC, so BAC, this one here, is congruent to this one here. So what I can see is I have angle, side, angle. So that's my reason, angle, side, angle, congruency, right? So that's my reason. And then the last thing I can say, because now I wanted to get to this, which is that BC is congruent to EF, right? BC, which is this one, is congruent to EF because I showed I had congruent triangles. So congruent triangles have congruent parts. And then we're done. All right, there we go.